All right, I know some of you are working at home on this calculator section and just wanted to make sure you had the answers to this and maybe a few of the other graphs on this particular worksheet to try to prepare you for tomorrow. In class we talked about how we, on this Ferris wheel question, we would take the equation and we would change it to its fireproof form so that we could find ABHK. And we did that. We were able to use the value of A to find the period, which was 180 seconds. Obviously, that went with question B right there about how long does it take for the person to make one complete revolution. Time 0 for the first question, that was plugged into the equation for T, and then you can use simple algebra calculations, and you can find out that the height above the ground was 95 feet. We found out the maximum height was 125. That was found by taking the center of the wave and adding the amplitude to come up with that value. And we also compared in class the actual Ferris wheel circle compared to the center, or compared to the wave. And if the first time that it reached the maximum height was 30 seconds, then 180 seconds later it was doing it over again. So that would be 210, and then obviously doing that again would be 390. Question 9 stops at 540 seconds, so adding another 180 was impossible because that would go over. We talked about that. Hopefully you were able to put the data in your calculator and then graph it. When we graphed it, we came up with all this really cool information, including the value of K, the center line, the amplitude, which gave us B, the period, which was 12 months, gave us the value of A at 6 over pi. We estimated this from our graph like we did in class, and that gave us our equation. You can either have it in fireproof form or in standard form, solve for Y. Either one. Part B, they asked me what the temperature was in September, and September is the month, it's the 9th month, and so if you plug in a 9, you would find out that you get 68.5. Make sure your calculator's in radian mode. Now, I'm not going to go through the basic sine function because I'm pretty sure you should know how to do that. Or the next page, because those are things, cosine, tangents, those are things you need to know. All that basic information is stuff you need to know. You can look all that up in your notes. Here's the picture of the graph for this one. I did a little bit of algebra over here to find out what A, B, H, and K were, putting it in fireproof form, and then I could find the period, the amplitude being 3 and pi, and then I could graph everything over here, finding my HK at negative pi over 4 and 1, because that's my center line at 1, and then that's sine wave, so it's actually on the curve, and then you could make the rest of the curve. Scale change rules were 1/2 x, 3y, and x minus pi over 4, y plus 1. On the next particular graph, I found the center line at 2, right? We averaged those, or center line at 1, and by averaging the high and the low, and the amplitude was 2, gave me B. I found H to be 3 pi over 2 because we are sitting underneath the maximum. And the period goes from here to here, that's 4 pi units. So the stretch on the horizontal axis was 2 from the original period. So I was able to write my equation, standard form, solve for Y. And on the back side, there's one more graph. It had a K value at 1. Amplitude was 1/2, so that's B. If the period is pi over 2, to repeat the cycle from one point to another place starting over again, then we've got to divide by 2 pi. Dividing by 2 pi is the same as multiplying by 1 over 2 pi, and so you find out that A is 1/4. Of course, I'm choosing an H value of 0 because that's on the way up the hill. If you chose an H value of pi over 2, yeah, you wouldn't be wrong. Or even negative pi over 2, but I chose 0. So I wrote my equation, fireproof form, standard form. There's a couple different, some of you probably would write it like x over 1/4. Some of you would multiply by 4. It's completely up to you on that one. So, see you in class tomorrow.